Hi, I'm Nigel Griffiths. I work in the Advanced Technology Centre in the UK, part of IBM Europe. This movie is about Ganglia, a performance tool that I've been using for a couple of years now, and I particularly like it because it's supported on the IBM Power-based machines, that System P, P series, and there's also the Power-based blades. Now, Ganglia is an open source project, and you can see the website at the top, so you can go and have a look at all the information and download the source code. It's very popular and it's developing fast. People are adding stuff to the actual code itself or adding add-ons that you can use to make Ganglia even easier to use. And I'd like to give a big thumbs up to the developers involved. It's a very impressive piece of software. It also runs on a wide variety of operating systems. You can see the list there on the right. Now, there are a few IBMers that are getting involved, and they've added extensions for the Power 4, 5 and 6 machines, looking at some of the performance numbers that we particularly want to track out of those systems. And we've provided downloadable packages for AIX 4, 5 and 6, and for Linux on Power, namely Red Hat and SUSE, but the other versions of Linux on Power also are available for Ganglia. We'd like to highlight the fact that these extensions from IBMers are being offered to the open source community to be included. Now let's have a very brief view of how Ganglia actually works. On the left hand side here we see that for each node or logical partition on our P-series machines we run a program called gmond, that's the Ganglia Monitor daemon. It's just a small daemon that we run on each machine, and it has a very small configuration file. And for a simple setup we just make one line change to that configuration file to give it the name of the cluster. These gmonds then actually talk to each other and share information. On the right hand side here, on a web server, which typically is Apache 2 but it could be something else, we run this extra process or daemon here called gmetad. This collects the data from one of the gmonds to find out all the performance data about the cluster. This has one configuration file too, very simple to edit and administrate. And it collects all this data and puts it into a round-robin database using another open source tool called RRD tool. Again, a very impressive open source tool that will keep the data in a small database that will not grow with age. Then if we look at the browser, we click on the website where we're running Ganglia. It calls these PHP scripts that actually extract information out of the round-robin database tool databases, and it builds up your web pages in your graph and then shows you back on the browser. This means that we don't actually create pages until we're actually looking at them and they're created dynamically. This saves a lot of CPU power. In fact, all of these processes take so little CPU power it's actually difficult to actually find them above the sort of noise level of daemons ticking around on your machine. On System P power-based machines we tend to run lots of logical partitions, and we put all the logical partitions of one particular machine into a single Ganglia cluster. Then when we look at this cluster we can see all the workload that's happening on one particular machine as a group. At the top right here we have a P505, it's a two-way machine. It's running 11 different operating systems in 11 logical partitions, and we put that as a cluster called Serenity. One of those logical partitions is actually running SUSE 9 and the Ganglia website. On the left hand side we have a bigger machine, it's an 8-way P550Q. That's running 7 or 8 logical partitions, again a mixture of operating systems, and that's in a Ganglia cluster called Sunset. We can of course put lots of other machines together in any way we like and put them into clusters. Particularly if we have machines that aren't running logical partitions, we could just use them as separate machines and put them into a bits and bobs cluster. Ganglia is a dynamic web page. It's best to actually just show you what it does to give you a feel for what it can do for you. Here's the default top page. We have a grid which is a grouping of all our clusters, and at the top here we have two graphs that are showing us what the whole of our computer center is doing. In this case I just have a couple of clusters. Talked about Sunset and Serenity here, we can see neither of them are particularly busy. Although in Sunset here we can immediately see that there's one host down. Now that might worry me. What can I actually do to find out what's going on there? If I just click on any of the Sunset graphs, I can have a look at the details. And if I scan down to the bottom here, this is a summary for each of the nodes in our cluster, and we can see that it's a partition here called WP13, and I remember now that I actually took that down. It was a temporary crash and burn logical partition, so we can ignore that. Now if we go back, I'd like to spend some more time looking at the Serenity cluster in here. Here we're just looking at two things, the load average and what's happening in memory of our cluster, to give us an overall view. I'll click here now on Serenity to have a look at that particular cluster. First thing we might note at the top here, I have 11 logical partitions and I have 11 hosts in here, and none of them down, which is good news. Got to be careful with this CPU total. This is actually the total number of virtual processors in our P-series machines. If we look down the bottom again, we can see that I have 11 machines running in here. The coloration means that this one's the busiest. They're in descending order of how busy they are. The mirror shade here is CPU used, which is the physical CPU used in our machine. And we can quickly get a view here of which of our clusters are busy. Do have to be slightly clever. If you see this little M, these are in milli, so these are thousandths. So for example, this guy here is using 1000 milli, so this is one CPU on this graph here, so he's using about half a CPU on average in here. These guys are using fractions of a CPU. When we see that little m, that means we're talking of thousandths. If I go back up the top here, we can see that we can control things that we're actually monitoring. For example, we're currently looking at CPU use, but we can look at any one of a large collection of different numbers in here. So we can look at the CPU used, a particularly useful one, but we could look at something, for example, are we using 64-bit operating systems here? Again, I scroll down to the bottom, you have a yes everywhere, good. We can do things like looking at what operating system we're actually running in our cluster. So we're using a virtual I/O server in this one here, and we're using some Linux and some AIX. Okay, which versions are we using? Look at the release. We can say this is AX6, this is AX5, and we have various flavors of Linux running in here. Here we have actually Fedora Core 5 running in this particular logical partition. And we can look at all these sorts of things. We can say what is the weight factor, is SMT switched on or off. For example, look at the weight. We can say, have we given all of these partitions a similar weight? Well, some of them are set to just over 100, some of them are set to 200, so these two are more important logical partitions in our cluster. But we like the CPU used, physical CPU used. We also note across here, by default we're looking at the last hour. We can change that immediately. We can look at the last day, for example. What's been happening here? This one, for example, has only been using this half a CPU for particular periods during the day, otherwise it's been very low. And we can just as easily look at the last week or month. Let's have a look at month. You can see here that the graphs actually run out here just at the beginning of week 1. So I actually built this Ganglia cluster just after Christmas, so the first week of the year. And again here we can see that this is the busy workload partition. We can see the peaks and troughs here. It's actually a batch job running at night, I think. We can also have a look at the global view of what this machine is up to. Let's go back to let's say the last day, and this graph here shows us the shared processor pool. All these workload partitions here are working out of a shared pool, and we can see the overall shared pool. We have 2 CPUs in here, and we're peaking at just over 1.25. Any graph with a blue border around it, this is an add-on for Ganglia, and it means we can click on here and get a detailed graph. So here we go. Each of the logical partitions is given a different color, and this red one here is this WPAR9 that we already knew was quite busy, and we can see him coming and going. There's a slight outage here. For example, I actually switched off all the Ganglia daemons as a little experiment, but we can see that actually happened here. So we can actually find outages on a particular machine by using Ganglia, which can be useful. If we got unreliable machines. But we can see most of these workload partitions are not doing very much. Just this red one kicks in every now and again in the evenings and nearly over midnight. Now that gives us a clue about which of the busy logical partitions is this one here. It's actually highlighted. And if we click on here, we'll actually look at this particular node, this logical partition in this case, and we can find out some interesting information about it immediately. Here's its host name. We know that it was booted on December the 27th. It's not capped, so we can go over its entitlement. We can see some other things here. 64-bit kernel, as we said. It's a logical partition. Down here it's a shared processor logical partition. We can also see the SMT switched on, how long it's been running, which version of AIX is actually running, and it's we're on a Power 5 base machine in here. This is actually the serial number of the machine, so if we needed to report problems, we've got that information already here. Down here we have that it knows about 2 CPUs. This is the virtual processor count, and they're running at 1.65 gigahertz, and this guy's got half a gigabyte of real memory and half a gigabyte of paging space. And we can see here the details of what's actually going on in this particular logical partition now. So we have the CPU details and the network details, blue area around this graph, so again we can click in here to find out some more details. And we can scroll down and see all the individual numbers here for this particular logical partition. CPU used we've seen globally, and now we can see the individual details for this particular logical partition. Okay, if we go at the top, there's a field here that we can go into. This should be blank at the moment, but if we wanted to extend Ganglia, if we have any script or tool on the operating system that can give us a number or even a string, we can pass this to Ganglia. It gets pushed up to the website and we can see the details here. If it's a number, Ganglia will actually start graphing that for us, so we can track that number from then on, and it'll auto-scale all these graphs for us. Okay, that's just a quick look around of what we can actually do with this basic version of Ganglia. Let's look at the Serenity cluster again. I have an extension up here that allows us to look at any particular period of time, and we've increased the amount of data points that the RRD tool actually captures under the covers. If we click on here, we can say, let's look from January the 1st to today. Now we'll find our graphs are actually covering these particular period of time rather than one of the last week, last day, last month, that sort of graphs. And again we can look at a particular period of time in here, what's going on. Very useful extension to Ganglia. Let's have a quick look now at another feature of an add-on of Ganglia called custom graphs. Here we see the graph here for network last hour, but we don't actually want to see that. We want to see what the overall I/O rate was through our network adapters. So if we go back up the top here and hit custom graph, we can decide exactly what we want to look at. Give it a name, and we can choose what we like here. The bytes in and bytes out are the network details, and we don't want a line, we want to stack these two graphs, and let's select that particular colour, and go blue and red. So now we can see the overall stats. In this case it wasn't very much I/O, but it was 50k in and out, and the colours we like. Well, that is it for this quick look around Ganglia, particularly running on the Power-based machines. Remember, you can get Ganglia information from the website at the top and the Persil.org website if you want the packages pre-built for AIX and Linux on Power to work on the Power-based machines.